Right, so welcome to another lesson on Clinton Visual Academy. Today we are going to be discussing forces and movement, and we'll look at the relationship between energy and then forces. So in our previous classes, we learned about forces and its effect on objects. And we also learned that energy. We also learned about energy and how it gives us the strength to do a lot of things. So now we are going to be talking about the relationship between energy and force. Now we know that for a body or an object to move from one position to another, a force has to be applied. Okay, we apply force by either pushing, pulling, twisting, squeezing, or any other way of applying force. A force can be defined as the pull or push of an object. So if you look at the image there, one of the boy is pulling, the other is pushing. Okay, one is pushing, one is pulling. So moving it away from you is pushing, moving it towards you is what? Pulling. Now energy, on the other hand, is the ability or the strength to do work. Work is done when a body moves an object through a distance in the direction of force acting on the body. Okay, work is done when a body moves an object in the direction of the force acting on the body. Okay, so to make something move, change direction, or stop moving entirely, you need to exert an amount of force on it. You cannot exert a force unless you have the energy to do so. Okay, so for example, when you move your table or your chair, your hand exerts a force on the table or the chair to move. The energy required to exert that force comes from the energy stored in your muscles. Do you sometimes ask yourself why it is difficult to lift a table than a book? Well, a table is heavier than a book, and because of that, you need to exert more force in lifting the table than in lifting the book. Right. So from this understanding, we can say that it is only when a force actually pulls or pushes something by a distance that is energy, that energy is involved. Okay, so until a force pushes an object in a distance, energy is not involved in it. Until it moves, then the energy comes in. Okay, sorry. So the distance from which an object will move depends on the strength of the force applied to the object. Okay, so in that case, it will be easier to pull an object with a lighter weight than a heavier one, like the book and the table. Okay, this means that in our daily activities such as weeding with the cutlass or cutting a tree, we need to apply more energy if we want to be successful. The force you apply to an object to move or to stop can be measured in Newton, and the energy you need to apply the force to the object is measured in what? Joules. Now let's look at machines like levers, pulleys, and then inclined planes. Okay, so we have also learned about simple machines. Do you remember? And how they help us to do work easily. Now, do you remember what simple machines are? Can you give some examples of simple machines you know? We are going to delve into simple machines in this lesson and then classify them as levers, pulleys, or inclined planes. We said simple machines are devices that help us to do work easily and faster. Okay, now we can also define simple machines as devices that allow a small force at one point to overcome a larger force at another point. Okay, it allows a small force at one point to overcome a larger force at another point. All right, so some examples of simple machines include scissors, nutcrackers, and so on and so forth. All these simple machines can be grouped into the following categories, like I said earlier: either levers, pulleys, or inclined planes. Let's look at some examples of these three forms of or categories of machines. A lever is a rigid bar that turns around a fixed point called pivot or fulcrum. It can also be defined as a simple form of machine which is made of load, effort, and pivot. The load in the object that is moved. The load is the oil that is moved, okay? The effort is the force applied at one end of the lever to move a load. Now the pivot or the fulcrum, it is the fixed point of the on the lever, which the turning takes place. So examples of levers are wheelbarrow, nutcracker, bottle opener, and shovel. Okay, they are examples of levers. When it comes to pulling, if you want to lift a heavy load from one point to another, no matter how strong you are and the amount of energy that you can apply, you may not be able to lift it. So with the help of a pulley, you can easily do what? Lift it. You can easily lift it. Now a pulley is a machine made with one or more wheels. Okay, a pulley is a machine made with one or more wheels over which a rope is looped to make it easier to lift. To make it easier to lift our things. To make it easier to lift things. Now let us look at some uses of pulleys. We can use pulley to dip and pull a bucket out of a well. Okay, we can use pulley to dip and pull a bucket out of a well. We can also use pulleys to hoist flag. Okay, to hoist flag or bring the flag down, to either hoist the flag or to bring it down. Now the last one is inclined plane. Inclined plane. So an inclined plane is a flat surface. Basically, it is a flat surface. For example, a smooth wooden board is a plane. A plane that is lying flat on the ground cannot help to do work. However, when the plane is inclined or slanted, it can help to do work. It can help in doing some work. An inclined plane can be defined as a sloping board used to roll a heavy object with less effort. Okay, with less effort. Inclined plane help us to use less energy to do work. Now a heavy load such as drums of oil and engine blocks can be raised onto a track with the help of a stopping plane. With the help of a stopping plane. Alright, so we have come to the end of this lesson also, and I hope you have enjoyed this lesson and you have learned something new today. Alright, so until I see you again, keep on reading your books and keep on studying harder. Okay? Alright, so bye.